Thank you. Thank you for the very concise introduction. All right. So today I'm going to talk to you about how to get your enterprise ready for the AI revolution. And this is a very involved topic. You're going to learn how AI works. You're going to learn how to choose AI technology. And you're going to learn about how your company must change in order to adapt to this AI revolution and be realizing value from it. So it's pretty involved, okay? How's the lunch day? Good? The food coma started to kick in? No? I see somebody is already like, heads down. Maybe they're just on their cell phone. Okay, so before I start, I want to just do a little bit of a mental warm-up exercise with you guys, okay? Just to make sure that you guys are sharp and ready to embark on this journey. Okay, so we're going to do this dingbat puzzles. Okay, I'm going to show you an image, and you're going to guess a phrase in 10 seconds, okay? What is this? 10. I understand. Easy, right? Okay, what's next? What? 10, 9, 8, 7. Forgive and forget, right? Good. Okay, next one. What's this? Scrambled egg. Excellent. Okay, you guys are good at this. Okay, what's this? Now it gets harder, okay? Now it gets harder. Huh? What's this? 10, 9, 8, 7, 6, 5, 4, 3, 2, 0. This is actually paradox. Doctor next to doctor. Paradox. Okay? What's this? Ping pong, yes. Why? P inside G and P on the G, right? It's using every part of your brain. It's using the spatial, verbal, and auditory, So what's the last one? 3 degrees below zero. Excellent. Okay. So it looks like you guys are mentally sharp and ready to embark. Okay? So let's begin. All right. Dark screen. So the concept of AI is actually not new, right? We all have our perception of what AI is. And thanks to the entertainment industry, we all see movies with AI in it, right? And they all portray these AI as a humanoid figure, right? That have like superior ability, above human, right? They're super smart. They work really fast, at speed of light. They remember everything. They work 24/7. They always learn and always get smarter. And what's even better is that they actually never even get tired and never even complain, right? So they're almost this like ideal employee. Who here would want to have an employee like this? I'm sure a lot of you do. I do. I want an employee like that, right? So let me just tell you, this is a very shallow understanding of AI. If this is your understanding of AI, it's not actually going to help you get your company ready for it. Because this notion of AI actually creates a fear, right? These AI are almost like the perfect role model employees, right? Okay? Basically, it creates a fear that when will AI replace us all? So if your employee is going to have a fear of this AI, do you think they're going to adopt this technology? Obviously not, right? Okay, so how can we have a better and more practical understanding of AI? Okay, so to answer this question, we have to step back a little bit and understand where AI actually comes from, okay? So let's take a look at a very, very brief history of business intelligence, okay? So I'm gonna use these stock trading data as an example, right? So first, when you actually get lots of data, is that you plot them, right? You look at them. And then when you have enough data that you can look at every single data point, what do? Yeah, you start to basically compute these summary statistics, right? You get these local trends, you compute these indicators, right? Some kind of moving average or something like that, right? So these are all what we call descriptive analytics, right? They summarize data that you already have. But after you do this for a while, you start to realize some pattern, and then you can start to build a model, okay? What's the beauty of having a model? Having a model means that you can extrapolate to regions where you don't have data yet, right? In this case, it's the future, right? You don't have the future data, so you can extrapolate it to the future, right? So when you do this, you basically move into what we call predictive analytics, okay? Now, having an eye into the future, right, is good, but you don't just forget about your descriptive analytics. You continue to do them, right? And then you make sure that you continue to do your analytics. But having an eye into the future is really good because now you could tell people what to do. Okay, for example, this is a good point to buy, right? Okay, and for example, and then when you do this, you basically move into what we call prescriptive analytics. All right, you're prescribing an action for people to take. All right, so again, your prescriptive analytic could tell you to sell right there, right? But of course, you continue to do your descriptive and predictive analytics, right? And your prescriptive analytic can maybe really smart and tell you to buy right there, sell 50%, and then sell the rest if you continue to go up, right? All right, so that's basically a very brief history of business intelligence, right? It has gone from descriptive to predictive to prescriptive, right? Okay, so descriptive analytic, a lot of you probably are very familiar with it. You've seen reports after reports after reports, right? So this is actually something that all of us have a lot of familiarity, but predictive analytic is something that a lot of people often misunderstood. A lot of people think that predictive analytics is all about forecasting. How many people think that predictive analytics is only about forecasting? A lot of you do. Don't be shy. Okay? I know a lot of you do, okay? Okay, but let me tell you, predictive analytic, the simplest application is forecasting. Okay, this is what we call a temporal predictive analytics. Okay, and the simplest example is a trend line. Tells you where the future is going to go, right? Which direction the future is going to go, right? There, you're basically trying to do this. So basically, what you're doing is that you're trying to take historical data, right there, right? This is the present time. You build a model, and then you feed in this historical data, and out pop future data. But there's something wrong with this picture. Future data doesn't exist, right? No one has future data, right? So this is actually a future prediction, okay? All right. I could tell you more about the details, nitty-gritty details of the difference later if you're interested. But so this is only the temporal predictive analytics. The most general form of predictive analytics is actually not limited to time domain, okay? So there, what you're trying to do is you're trying to take data that you have to make an estimate of data that you don't have. That's what you're trying to do, okay? So now you can see that temporal predictive analytics is just one special case of this, right? The data that you have are historical data, and the data that you don't have are future data. And in fact, those are data you can never have, right? So the general predictive analytics, what are some examples of these? So I work a lot on social media data. So one example is, for example, social media influence algorithm. You could score people and how influential they are. Wouldn't it be nice to know who's influential in social media, right? But you don't have that data. But what data do you have? The data that you have are basically social media interactivity data, right? You could get who followed who retweeted who likes whose content, who replied to whose comment, blah, blah, blah. All these are social media interactivity data that you can have, but you could put it into this model and then out pop the influence score that tells you how influential this person is. Okay, so that's one example of it, right? Another one of these is actually sentiment analysis. How many people here are familiar with sentiment analysis? A lot of you know sentiment analysis, right? Okay, so there, what you're trying to do is the data that you have is basically text, any text, right? Whether it's a tweet or a news article or a blog comment or tweet or anything, right? Or email, right? Any text, you put it into sentiment classifier, and the out pops basically tells you whether you have a positive or negative sentiment about a particular topic or entity, right? So that's using data that you have to estimate data that you don't have. Okay, so that's in fact, so just keep in mind that there's actually no time in these two domains, these two examples, right? You could put in, like, for example, Shakespeare's Hamlet in there and see when Hamlet is actually, have a positive sentiment or negative sentiment about the world, right? For Hamlet, he's probably going to be very, very negative most of the time, right? If you read Hamlet, right? So you could put in, like, old stuff, right? So what are some other examples that you know of? This mouse is very sensitive. Okay. What are some other examples that you know of? Come on. You guys are mentally sharp, right? Huh? Image recognition, right? You have an image, you're trying to give an estimate of what the label is, right? Whether it's a dog or cat, right? Some other example. Wireless call? Phone call? Okay, that's sentiment analysis, right? How about like gender inference, right? What you have is what they talk, their speech, how they talk and how they serve the web. These are behavior data, and you're trying to infer whether they're male or female, right? There's no time in this example, right? You could put in your grandma's behavior in there, and you will predict your grandma's male or female, right? So, okay. So this, in fact, most of the time, the non-temporal, the general predictive analytics is actually more useful than the temporal version, okay? Because you can estimate data that you don't have, okay? All right. So now let's move into prescriptive analytics, right? So as I mentioned before, in predictive analytics, right, the simplest example is a trend line, right? And the general predictive analytics is actually not limited to time domain. You've seen a couple of examples of that, right? What is the simplest example of a prescriptive analytics? Any guess? Any guess? No guess. Okay. It's actually a GPS navigation system, okay? Because what does GPS navigation do? You tell me where you want to go, and I will prescribe you a route to get there, right? It's prescribing actions or sequence of actions for you to take in order to get to your destination, right? But just, like predictive analytics is not about forecasting. Prescriptive analytics is not just about prescribing actions. It's actually all about optimization. Think about this. Why do you think you prescribe this particular route? There's actually many, many routes to go there. You can actually go this way and come back this way. You can go around here, come back. You can even go around the Earth and come back the other way. Why do you think you prescribe this particular route? Yeah, early GPS optimizes for the shortest distance, right? So that's why this route gives you the shortest distance to get there, right? But now GPS is getting smarter, so you actually optimize some other objective function. For example, shortest time to get there. So you're taking the modality of your mode of transportation, traffic, and all this stuff, right? So these are actually optimization algorithms underneath. Okay, prescriptive analytics is all about optimization. Just like predictive analytics is all about estimation. Okay, so just like predictive analytics is not limited to time domain, prescriptive analytics is actually not limited to the prescription of routes in geospatial domain either. Right? You could prescribe business strategy. For example, I want to increase my sales by 20% by the end of the year. That's where you want to go, okay? And your prescriptive analytics system can be really, really smart and tell you what you need to do in order to get there, okay? If you have all the data for it, okay? All right. Okay, so what are some of the other examples of prescriptive analytics system that you know of? Do you know any other examples? Staff rostering. How is that prescriptive? That seems like predictive analytics to me, right? So, okay, so maybe I need to understand how that works. Okay, so what's some of the ones that you know of that you use every day? Search engine. Search engine is actually a prescriptive analytics, right? There's infinite number of content that you can read. Why do you prescribe you those things that you on the search engine result page? What is it optimizing? Relevance. It's optimizing relevance, right? Okay. What are some other ones that you know of? Recommender system. Right? Recommender system is also a prescriptive analytics. Prescriptive analytics, right? Because there's infinite number of content that you can read. Why watch this particular movie? What is it optimizing? The similarity between the content and your preference, right? That's what it's optimizing. So if you're trying to understand what prescriptive analytics is, just ask yourself, what is it actually optimizing? Once you get that, you will have a very good understanding what prescriptive analytics is doing, okay? All right, so now you have a much better understanding of predictive and prescriptive analytics, right? What's next? What's after this, right? So you know that business intelligence or business analytics have evolved from descriptive to predictive and then to prescriptive, right? So what's after? Huh? Okay, so, all right. To answer this question, we have to take a look at what role do business intelligence play in business, okay? Business intelligence basically play what we call a passive decision support role. What does that mean? Passive decision support role means that it is actually not making the decision for you. It's helping you make decision, but it's not making the decision for you, right? Regardless of whether it's descriptive, predictive, or whatever analytics, right? Humans always make the last call, right? You could show you the stock market is going to crash tomorrow. You could decide whether you want to sell your portfolio or not, right? It could tell you should sell this particular stock, but you still decide whether you want to execute that or not, right? It could tell you what to do in order to get home, right? But you could say, I want to go around and go take a scenic route, right? You could decide what to do. Humans always have the power to decide what to do, right? And that's for good reason, because traditionally, all these analytics have limited accuracy, right? No matter what kind of analytic, what kind of model you have, they always have limited accuracy. And the accuracy of these analytics is actually limited by 3 factors, okay? So let's take a look at why that is. Okay, so this is our data volume have increased, right? From, bytes in punch card. Remember those days? Some of us may remember those days, right? Now we're kind of in this age, right? We're in kind of a petabyte range where everything is stored in cloud, but in the future, we're going to have quantum holographic storage as well, right? So this is to come, right? And our model actually gets more and more complex too, right? It's gone from like kind of simple statistical model to, model that actually mimics our brain, right? How our brain works. So model gets more complex, and more complex the model is, the more data you're going to require to fit it, right? And once you put in those data, the results of these analytics, right, it obviously depends on the data quality, right? If you put in garbage in there, it's going to have garbage out. You heard of this before, right? And model quality is the second factor, right? If your model is missing a component that you're not taking into consideration, then the result is not going to be very accurate, right? And finally, CPU cycle. You may get the answer, but if it takes you a year, it's not going to be very useful, okay? All right, so this is a little bit of a history, okay? So I'm just going to go through this very quickly, but the important point is that is that early on, even in the 1950s, we actually already have a fairly good understanding of the theoretical models that we're dealing with, okay? And so back in the 50s, we already have models. These are like 2 or 3 layer deep neural networks, right? But what's limiting back then is actually the amount of data, right? Even if you have data, they're not digitized, so you actually can't use them, right? And also limited by computing power, right? But over the course of like the last 50 years or so, right? Basically, everything increased, right? Our model understanding increases, but our data volume and computing power also increases. But the interesting thing is that our understanding of the model actually increases linearly, whereas the increase in data volume and computing power increases exponentially, okay? This is due to Moore's law. I'm sure all of you know the Moore's law, right? Okay, so that means at some point, the computing power and the data volume is going to overtake our understanding of the model, right? By 2000, we already have distributed computing. What that means is there's virtually no limit in computing power, right? Because it converts this computing power as a limit into economic constraint, right? Whoever has the most money to buy the most computer, you're going to have the more computing power, right? It changes this computing constraint, CPU constraint, into economic constraint, right? And by 2010, right, we also have GPU. But what's big advancement in 2010 is that we even have big data, okay? Now, big data basically lift the constraint on data, right? There's no more constraint on data. You pretty much have as many data as you want, right? Okay, so what does that do to, what does it allow data scientists like me to do? Now, of the 3 factors that's limiting my analytic results accuracy, 2 of them are gone, right? What does that mean? That means I could use as sophisticated a model as I want. I could use models basically that mimics the human brain, right? Deep neural network is actually, deep network, deep learning, right? These are actually just models that mimics how our brain works, right? Recurrent neural network is simply a model that mimics memory, right? LSTM, another one that mimics the effect of memory, right? So now, when you have pretty much no limit in data, computing power, and also the model, right? What happened to the results of these analytics? They become very accurate, right? They become very, very accurate, right? What does it mean to have a model that's really, really good? That means to start to match human experts' prediction, right? Okay, now if it's matching human experts kind of prediction every single time, right? Not every, no, okay. Nothing's 100%, right? But pretty much all the time, right? Right? Do humans still have the last say, right? What happens when machines agree with human experts pretty much all the time? Do humans still need to have the last say? You could, but then the humans basically would say that like, I agree, 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 right? Pretty much all the time, right? Is that necessary? Probably not, right? Probably not necessary, right? So this is actually the beginning of artificial intelligence. You simply automate it, right? There's no need to have a human saying, I agree all the time, right? You just automate it, right? So this is actually the beginning of artificial intelligence because traditionally, going from data to decision to action, right? That is a human's job. We decide what to do. Regardless of what the data or the model tell us, we decide what to do, what decision we make and what action we take, right? We decide that. But if we automate this, right, because the model is good enough, right, the decision will actually be good enough to match a human expert pretty much all the time, right? You can automate this. Basically, now data is driving decision and driving action automatically, right? And this is here today, right? Today we already have algorithmic trading, right? Who here uses a robo-advisor to manage their portfolio? I do. I don't have time to manage my stock. I just let the robot trade for me, right? Rather than telling me what to buy, when to sell, just trade for me. Buy and sell for me, right? You already know what the best action is. Just do it, right? Automated loan origination, right? If the person meets the criteria, give him a loan. Why do you need a person to check off all these boxes, right, in order to give him a loan, right? Remember what is the simplest example of a prescriptive analytics? What is it? Simplest example of prescriptive analytics? I'm just testing to see if I remember. GPS, right? Going back to the GPS domain. Rather than telling me turn left, turn right, take me there. This is AI, the beginning of AI, okay? This is the beginning of AI because now this AI may not be very, very smart yet, okay? So we have to ask the question of what gives AI its intelligence? What makes it smart, okay? Now, if you actually do a little bit of research yourself, okay, and Google around, you may find this picture floating around the internet. Okay, you see that, people will say that, okay, what makes AI smart is all the deep learning development that's happening in recent years. Okay, and what is deep learning? Deep learning is a kind of machine learning. What is machine learning? Is a kind of AI. Okay, now this is actually a picture that is actually wrong. Okay, you should not remember this picture. Okay, because deep learning is in fact, or it's not completely wrong. Okay, deep learning is actually one kind of machine learning, but machine learning is actually not a kind of AI. Okay, machine learning is actually using AI, right? But in this is a Venn diagram, right? So the Venn relationship had to be consistent, right? So if you think that machine learning is using AI, then deep learning had to be using machine learning. That's not true, right? And if deep learning if the Venn relationship here means it's a subset of, right? So deep learning is a kind of machine learning, then machine learning should be a kind of AI. So this is not the case either, right? So this Venn relationship is inconsistent. So this picture is wrong. Don't remember this. Throw it away. Okay? Let's try to give you a picture that will illustrate how AI really, really works, okay? So everything actually starts with data, big data, hopefully, okay? So otherwise you're not taking advantage of the big data that you have, okay? So now, data scientists basically turn this big data into a model. And data scientists use a very powerful tool to do this, and that is called machine learning, okay? This mouse is really sensitive, okay? So anyway, so machine learning here is actually both a noun and a verb, okay? It's like Google used to be a noun, but now people use it as a verb as well. Same thing is happening in machine learning. So machine learning as a noun is really just a bunch of algorithms that data scientists use to turn big data into models, right? That's what they do, right? And as you can see, like here, deep learning is actually a kind of machine learning. It's a one kind of algorithm. By far not the only one, okay? It's a very popular one because of all the recent success it has, but there's actually many, many more. I could fill up several slides with names that doesn't make sense to most of you, okay? So, but it includes like simple models such as decision trees as well, right? So all these are machine learning algorithms is at a data scientist's disposal, right? And so what about a verb, the verb form of machine learning? Machine learning as a verb is simply the process of turning big data into a model. That's what data scientists do. We do machine learning, right? We turn data into a model, right? Depending on what data you have and what model you're trying to produce, right? You will pick different algorithms that you've seen earlier, right? From here or from a much bigger list, right? Or combinations of them, right? To produce a model that you want, okay? So that's the verb machine learning, all right? Now, a lot of people often, one of the things the biggest mistake I've seen in the industry is that people often say that, oh, I use machine learning to build my model, so my model is smart, my model is AI, right? This actually is a result of that picture that I told you not to remember, right? Because you're like, I use machine learning, so machine learning is a subset of AI, so it's got to be AI, right? That's actually wrong. It's not true, okay? Having built a model using machine learning doesn't mean you have AI, okay? Machine learning is not AI, all right? Now, some of it is actually due to history, okay? Back in the, I would say, 80s, there's a kind of system called the expert system, right? Expert systems are systems that mimics how experts solve problems, make decisions, right? And if you actually look under the hood, right, what this system actually do is actually just a bunch of if-then statements. But back in the 80s, they were considered one of the earliest success of artificial intelligence, right? So, but today, nobody will consider a bunch of nested tree of if-then statement as AI, because a fresh college grad computer science major, right, could come out and just code this up. Everything is hard-coded, right? This model actually never learned, right? So, for example, right, you could say that if a doctor is trying to determine if you have lung cancer or not, you're going to say, okay, if you have chest X-ray, right, then I'm going to see if you have nodules. If you have nodules, then I'm going to say, is the nodule kind of circular shape or is it irregular shape? If it's circular shape, then you have to check the growth rate. If it's growing faster than a millimeter a month, then most likely you have malignant cancer and you're going to die, okay? If it's growing less than a millimeter a month, you might still have tumor, but it may be benign, so you're okay, okay? And if you don't have a chest X-ray, then there's another path to determine whether you have cancer or not, right? So these are conditions that are hard-coded, right? This model actually never changes until the expert kind of reprogram this nested if-then statement, right? Okay? So this is not an AI by today's standard, okay? Okay, so now let's take a look at what actually makes AI, right? What makes AI really smart, right? So as I mentioned earlier, a model could give you some output, right? Some results, right? And based on these results, some decision have to be made, right? And the decision often leads to some action that needs to be carried out, and some consequence of those actions, the outcome is a result of those actions, and those need to be feedback into the analytic result in order for it to work well, okay? Now, these analytic results typically are prescriptive analytics, okay? So why do you need a real-time feedback? Why do you need this to feedback there? Why is that necessary? Actually, pretty much all the prescriptive analytic systems have to have a real-time feedback in order for it to work well. Think about it, yeah? Huh? Optimization, yeah? But you're doing optimization with the model already, right? The reason why you need it is because you need real-time response, right? Because all prescriptive analytics have to be actionable, right? If you take an action a month later or a year later, the situation has changed already, right? Think about this. The example of a GPS, right? What is the real-time feedback for GPS? Not traffic. It's the blue dot that shows you where you are, okay? The blue dot that shows you where you are is the feedback, right? Think about how good a GPS would be when you don't have that blue dot. Tell you to turn left here, this one, the next one, right? You'd be lost, right? Okay, so you need this feedback in order for prescriptive analytics to work, right? Okay, so as I said earlier, traditionally, human makes decisions. We always make decisions here, right? But what about actions? Actions are actually, some of it can actually already be automated by machines, right? Especially those in the digital world, because all you involve is just lines of code, right? Most of the stuff in the digital world can already be automated. Most of the action can already be automated, right? In the physical world, humans still have to take these actions, right? Because advanced robotic hasn't advanced as quickly as we want to. Maybe that's a good thing. Okay? And the feedback, right, traditionally has also been collected by human as well. And human basically use a survey to collect those data, right? And obviously, surveys are very, very slow, right? It's not going to achieve this real-time feedback to make your analytics work really well, right? So the first thing we have to fix is basically this feedback had to be tracked automatically, right? And that can already be done fairly easily today, right? You just have to instrument some kind of tracker, especially in the digital world today, right? And with IoT, with different sensors, right, you can even do this in the physical world in the near future, right? Okay, so that can be done fairly easily, right? But as I said earlier, if the model is good enough, right, then we can automate this decision as well, right? Now, we don't want to automate this completely, right? So there's still a little bit of that yellow color there, right? Because that's because, you know, humans still may disagree with the model sometime, right? And you can always override that. But most of the time when you agree with it, you should just automate it, right? All right? So now, as I said earlier, right, most of the stuff in the digital world can already be automated, right? So in the future, hopefully, you know, when robotics become more advanced, everything could be, all the action can be automated as well. This mouse this clicker is really sensitive. Okay. All right. Okay. So now, this feedback loop here has no more human in there, pretty much, right? That means it could go really, really fast, right? But there's still one problem with this picture. Anybody see what's wrong? Yeah, the person here, right? That means this model actually never get updated, right? Until the data scientists go and collect more data and go through this machine learning process to update the model, right? But one of the advantage of having this entire feedback loop, right, be all tracked by machine is that now everything can be tracked and be digitized, right? Because everything is automated by machine, so everything is digital and can be tracked and digitized, right? So now if everything can be digitized, they become data that could be fed into your big data store, right? And that changes your big data. Now you just have to automate this machine learning process, right? Basically, now you could update your model in an automated fashion, okay? Okay. Now, basically, we could do this completely automatically, but usually you don't want to do that because machine can actually learn things that are wrong, that are not good, okay? We're going to discuss why that is the case, okay? So, okay. So semi-automated, right? Now, once you do this in you have this entire loop kind of in this bigger feedback loop, right? In a semi-automated fashion, right? Then this model will get better and better with every use of this model, right? Every time you make a decision, right, the outcome is going to feedback to your model, and it's going to update the model so that the next action that you prescribe is better than the previous one, and it gets better and better every single time you use it, okay? And this model will become really, really good at approximating and actually modeling this process, right? You will know exactly what outcome is based on what decision you make, right? Become really, really good at that, okay? And this is what we call the learning loop. The learning loop is actually what makes AI smart. What's what gives it intelligence, okay? Because now, every time, right, you use the system, right, so the outcome is going to become digitized, right, and then it's become part of your data, and then you update your model so that the next action you prescribe is better. It gets smarter every single time you use it, okay? All right, this is how AI learns, okay? And this is actually how the AlphaGo is able to beat the world champion in the game of Go, right? AlphaGo was actually never trained with strategists from the world champion, from Lee Sedol. They were trained with professional player, they're good player, but far from being a champion, right? But once AlphaGo is able to be good enough, right? Remember, good enough meaning like you can actually play against a human and be pretty good, you know? Then what happened? You can make AlphaGo play against AlphaGo, right? Now, what does that do, right? Well, if you play a human, right? AlphaGo is going to play a human. It's going to take several hours to play a game, right? But if you play AlphaGo against AlphaGo, you could play 1 million games in a day, probably, right? So what does that mean? The implication is that it could probably make all the possible mistakes that a human could ever make in their entire lifetime, probably 2, 3 lifetimes, right? And that's how it's able to beat the world champion. Okay? Think about the implication of this. Making errors and learning from that making mistakes quickly and learning from that every single time, right? And so that you don't make the same mistake again, makes you smarter and better. Okay? Same thing, we do this, we're learning this, like with agile development and everything, right? So, but another proof point for you there, okay? All right, so as you can see, right, AI could do a lot of things because, a lot of people often ask me, what can AI do? So I'm gonna ask you guys, stop asking that question. That's basically trying to ask, what can the children become, right? It's not a relevant question, right? Instead, ask yourself, what can you digitize, right? Because this is really, okay. Because AI can pretty much do everything that we can do as long as we have the data to train it. So as long as you can fully digitize the process, you can actually train the AI to do pretty much whatever a human can do, as long as you can fully digitize it. Not just part of it, you have to fully digitize the entire process, okay? Okay, so the next, okay, this is really weird. My clicker is really, really sensitive. Okay, so now you have to, in order to benefit from AI, you also need to pick the right tool, okay? And because AI is such a hot topic, pretty much today, everybody out there, every vendor is saying that they do AI, right? Okay, so you need to know how to pick the right tool for the problem that you're trying to address, okay? So, and also from the previous slide, you know that pretty much AI can do anything, right? As a result, there's like thousands of different applications of AI, probably tens of thousands, hundreds of thousands of applications of AI. But there's actually 4 that's actually very big in the recent year, okay? There's 4 major categories of AI applications. The first one is what we call perceptual AI. So perceptual AI are basically, you all have experience with this with Siri and Alexa and Google Assistant, right? So these are perceptual AI because they mimic the higher perceptual and cognitive functions of human, right? Now these AI basically have ability to see things as we do, to talk back to us using our language and understand our speech, right? So the primary applications of these perceptual AI has been human-computer interaction, HCI, right? It's pretty obvious because now you have a machine that could talk like us and see things as we do, right? Then obviously you're going to interact with them a lot better, right? Okay, so that's first class of application here. First big application here, right, is perceptual AI. Second class is basically, second wave of application is internet AI, right? So the biggest application there is recommender system, right, or personalization engine, right? So Amazon and Netflix are some of the pioneers, but pretty much nowadays, pretty much any website you go to, right, they could track your data and what content you view and analyze it and actually feed them into this type of this internet AI, right, this AI, in order to learn your preference and guide you to content that's more relevant to you in the future. So every time you use it, right, it's going to actually learn your preference better and recommend content that's better for you the next time, right? So internet AI, easy, right? Okay. Another example, a big wave recently is autonomous AI. So the biggest application here is basically driven by, I would say, the autonomous vehicle, self-driving car. Okay. So, but it has huge applications in, I would say, robotics and connected machines and IoT, because it's all about machine talking to machine or parts of, components of the machine talking to component of the machine to enable them to function more autonomously, right? Okay, so this is autonomous AI, another big class, okay? Last class is what we call business AI, right? Business AI is, the biggest application there is business decision and automation, all right? And these tend to be very, very specific to the business domain. As you can see, right, you have algorithmic trading is actually one of them, right? And machine-aided medical diagnosis. Actually, Watson actually do a lot of these machine-aided medical diagnosis, right? Pros is actually one of these business AI too, okay? Because we recommend prices and how we optimize your revenue, all right? So this is actually business AI, right? Now, because everybody out there is trying to say that they do AI, right? So it actually creates a lot of confusion. Very often it is the case that there is a business problem, and every company, you all have their legacy business logic to solve this problem, right? And a lot of people, because everybody wants to jump on this AI bandwagon, right? What they do is that they just put a perceptual AI on top of the business legacy business logic, and then they declare win. They say, okay, now my system is actually smart. I have AI in my system, okay? That's not a false claim, okay? is real because that AI, perceptual AI, is one kind of AI. But if you understand the learning loop, you will understand what would this perceptual AI do to the system. Think about this. The more you use it, right, the more this perceptual AI is going to interact with you better, right? It's going to learn your business domain, your business jargon. It's going to learn the way you talk. You may even start to understand your accent, if you have accent, right? So you're going to, so the system is going to understand you better, right? But what's actually solving the business problem is still the same old legacy business logic, right? That part hasn't changed, right? Now that is not to say that these AI have no value. Perceptual AI have lots of value, right? But the value has primarily in this increase in employee productivity, right? Instead of sitting in a bus, right, or in a car, right, you could actually tell your digital assistant to help you send a note, send an email, right, set up a meeting, right? Instead of waiting in line for coffee, your digital assistant, you could tell your digital assistant to fetch you some data, right? And those are things that are all done traditionally by legacy business logic, right? Fetching a data, just a query, right? It's a dumb query that never changes, right? So they do have value, but the value is increased productivity, okay? Now, how is Pros different? Pros basically have these business AI. Every time you use it, it's actually going to learn to solve your problem better and smarter, right? So the value proposition is day and night different, okay? Smarter and better decision every time you use it. We have a tool called opportunity detection, right? Based on so it's going to recommend you opportunity to go after, right? To your sales representative to go after, but based on what opportunity the sales choose to go after and which one did they actually close, it's going to be able to recommend better and more relevant opportunity for them in the future, okay? So that's how business AI is different from a lot of the vendors out there just putting an perceptual AI on top of the legacy technology, okay? All right, so a lot of, I would say, these data savvy or innovative company, they actually have innovations in pretty much all four categories, right? So for Amazon, for example, is one example, right? Amazon have their Alexa right here. They have their recommender system in their Amazon.com, right? People who buy this also buy that, recommender system, right? Right? They also have autonomous AI. Have anyone visited their Amazon fulfillment center? There's very little human in it, right? Their warehouse is actually mostly run by robots, right? They're just robots just shuttling product from one place to another, right? So they all run by this autonomous AI, okay? And Amazon also has the business AI, because Amazon, you know that if you actually shop on Amazon, right, or track a product, right, you know their price actually changes based on the market demand, right? Recommending the best price for you to price at, right, is actually a business AI, right? So Pros is also, doing this as well. So we also have, not only do we have these business AI that we have for the last 30 years, right, we also have our perceptual AI too, and that's Monet. So Monet is not any different than any other digital assistant. The only difference is that she actually has access to this business AI. What makes her different and smarter than other digital assistants is she has access to these business AI, okay? All right, so how can you truly take advantage of this AI trend, right? Now, selecting the technology is the first step, right? How can you truly leverage AI, okay? So this is a problem that I encountered when I was speaking in Istanbul at another conference. I have to get across the Bosphorus Strait, okay? From here to here, green to red dot, okay? So guess what happened when I key in the address of my destination? It's going to tell me to go around this loop, kind of go around this way, right? Now this is kind of a little bit counterintuitive, right? If you don't know the geography of the region, right? You can see that tower is where I want to go, but it's telling me to kind of go away from it, right? If you look at the data of the distance from your destination, it's actually spend more time getting away, right? It's spending more time getting away. Only the last third of it is getting close to it, right? So this is a little bit counterintuitive, right? I'm trying to go there, but you're telling me to go here, right? You're telling me to go here and further away. But what happens if you don't trust this prescription of route? You're going to turn around and say, okay, I'm going to get closer to my destination. Eventually, you're going to hit water, right? And guess what? You have to turn back and go follow the same route again, right? And guess what? You will arrive at your destination even later than before, right? Now, we understand geography, right? So we understand that we can't drive through the strait, right? And unless you swim, right? So right? I'm not a very good swimmer, so it's not going to help. What if this was in a different domain? What if this was in the financial domain? This is actually, okay. What if this was in the financial domain, right? What if I want to invest $1 million and get 400%, say positive $3 million in 6 years? What if the prescription was that so basically you're starting here, you want to get back this much, right, in 6 years, right? What if the prescription that you had to lose $2 more million? Are you comfortable with that? Are you okay with that? Today, the biggest problem with human not able to leveraging AI is a trust issue. Okay, we don't trust AI enough. Okay, it's really hard. Okay, you could say, okay, now let's put in some constraint, right? What if I don't allow the system to lose more than, say, $500,000 at a time, every year, okay? What if the prescription was this? What if the result was this? What if you don't make any money for like 5.5 years, and in the last 6 months you make all the money back? Are you comfortable with that? Are you okay with that? Can you sell this to your boss? It's going to be a hard sell, right? But if you don't trust it, what's going to happen? You may eventually run into water, right? And you may actually lose more money and not be able to make those money back, right? So in the geographical domain, right, we understand how geography works. So we can understand why, a GPS prescribes a certain route for us. But in these other domains, right, the landscape could be so complex that even if you look at it, you don't know what the best route is, right? And we just have to trust that AI actually have this purview, right, that could actually guide us through this maze, right? So not only do we have to not be afraid of AI, we have to learn to trust AI and work with them in order to really benefit from AI, okay? Now, there's a requirement that AI had to be good enough, right? If it's not good enough, how can you trust it? AI had to be good enough, right? Have anybody here used the GPS route called Waze? Yeah, a lot of you do, right? Have you ever, if you use it, those of you who use it for the first time, right? Try to remember when you use it the first time. Have you ever wondered, like, why does it guide me down this small blind alley that I never go, right? It's kind of weird, right? But eventually you kind of say, okay, let's try it. Right? I have some time, I'm going to try it. And guess what? Eventually it gets to your destination faster, right? So it's actually working. It's good enough, right? So that it builds that trust. If one time you followed it through this blind alley and you get to your destination later, right? Good luck. You're not going to use Waze ever again, right? It has failed your trust, right? Okay? So how can you make sure that AI is actually good enough to start with, right? As I said earlier, right, this AI is garbage in, garbage out, right? You have data coming in and then data coming out, and the result of these analytics, right? And if you automate these, that's essentially what AI is, right? Now you learned that today, okay? If you have garbage going in, you're going to have garbage coming out, right? Basically, your AI is just going to be as good as your training data. So the question is, where do you get good business operation data? Where do you get that? Or how can you get that? How can you get that? You need to digitally transform your business, right? You need to start digitizing your business, right? Just turn all your business process, communication, operation into a digital process that can be tracked and become digital data that AI can use and learn from, right? So you heard this before, right? Digital transformation, you heard this term before. This is another reason why you need to digitally transform your business, okay? At a high level, digital transformation is really, really simple, right? Just the adoption of digital technology to change how your business operate, right? Now, but in reality, in practice, this is actually very, very difficult, right? We know that this digital transformation is a long journey. It involves technology, of course, but it also involves changing people and process and eventually the culture, which is very, very hard, right? And obviously, it requires good technology, but it also requires good strategy, program, and execution, okay? So this is actually another workshop that I won't have time to go into, but I just leave you at this for the time being, all right? So in order to fully leverage AI, you actually do need to get to the point where you digitally transform your business, okay? So for the time being, I'm done. Any questions for me? Have I lost all of you? Okay, do you use that mic there?
Hi, Sangeeta Agarwal from Accenture.
Okay, great.
Question, you spoke about a trust, and we still don't trust AI as part of both decision and then subsequently action.
Yes.
Where do you see the algorithm fairness testing or data bias detection in the overall scheme of stuff which you spoke about so far?
Where do I see what?
Algorithm fairness detection
Fairness
or data biases, which
data
then
bias.
can, because
Yeah.
the reason we don't trust is that we don't know if the bias in the data is then influencing the machine recommendations.
Yes. Remember earlier I said that you could do this machine learning loop completely automated, but you don't want to. Usually you just want to do it semi-automated. This is where a human comes in, okay? One example of this is for a bank actually tries to build an AI that actually lend people money automatically, okay? But one of the attributes that the AI picked up is race, okay? It turns out that race actually is heavily correlated to the people's default rate, right? But you can't use that, not legally, okay? So this is where human have to go in there and remove that variable. Variable 278 could be race, you can't use that. You have to remove it, right? This is where human comes in. You have to teach AI to learn the right thing, okay? To remove those biases, okay? Any other questions? No more questions? Okay. So I will be at the pros booth in the exchange for the next, half an hour, So if you want to have a further discussion on how to start your digital transformation or discuss deeper about how AI actually works, stop by. I'll see you there. Thank you very much.